45 in section, what was it? A3?
8.3.
A3. That's the one that says why. I'm sorry, wait. 45? X greater than -4. Y less than -2x plus 3, okay. So there's one problem on the board, but technically that one problem is made up of two problems, right? And that's a problem in itself. And then there's another problem. And you just kind of solve each problem on top of each other. Because when I shade a certain section, that means all those points work. So if I shade for this guy and I shade for this guy, what points work in both? Wherever I shaded twice. So it's where the shading overlaps. So how the hell do I do this first one? So what's a little bit weird about that first one? There's no Y. Why is it why? Yeah. Then you got to think what special case I'm in. My God, Jeff. What special? Yeah, I think I heard it. What kind of line is that? Vertical line. I like it. My God. Okay. So there's a vertical line. X greater than -4. So here's -4. Vertical line. What kind of line? Dotted, dashed, whatever word you like better. Greater than that. Yeah, that way. Right, there's no up and down. It's pure X, and X is left and right. So where the X is bigger than this, that way. Now how do I graph this dude? What do I know about this guy? Yeah, the y-intercept is 0, 3. Good, down 2 over 1. Down 2 over 1. What kind of line is it going to be? Dotted. Or dash, whatever word you like better. Make this red one a little longer. And I'm going to shade less than. Yeah. All right. So less than, I'm going to shade this way. And again, if you like, you can plug 0, 0 in and see that 0 is less than 3. Right? If we put a 0, 0 in, it's a true statement. That's why I'm going to shade in the direction of 0, 0. Or the shortcut is shade down if it's less than. All right, so where's the answer going to be? Yeah, this triangular area here. So however you can, you just make it really clear that that's the answer. You can like really just cross hatch it, whatever you got to do to make it clear. You guys with me? Yes.
How do you know when you're making a graph and a line?
How do I do what now?
How do I know when you're making a graph or when you're making just a line?
So the key on most of these problems is going to be two variables, which requires a true plane, XY axis stuff, right? There are problems like this first one that have only one letter, and they're going to have to be very explicit to graph it on an XY plane. So in a test, if I gave you that one by itself, and I wanted you to graph it like this, then I would give you the XY plane. Yeah, that's telling you that you have to graph that vertical line. I like it. I said something offensive, which is not surprising for me. Okay, yes?
So you always multiply by 0?
So one way to do this is to use a test point. So I graphed a line here, right? Cool. I graphed a line. Now if I use 0, 0, because that's on one side of the line. If I plug 0, 0 in as a true statement, is 0, come off there, is 0 less than negative 2 times 0 plus 3? Is 0 less than 3? So when I plug 0, 0 in, does it work? Yes. Therefore, that entire side has answers, right? If I plugged a point over here, pick a point over here. Let's say pick 2, 2, 2. What should happen when I plug 2, 2 in? If I plug 2, 2 into this, what should happen? It should not work. Let's see. If I plug 2, 2 in, I get 2 less than negative 2 times 2 plus 3 is 2 less than negative 4 plus 3 is 2 less than negative 1. No, it didn't work, just like we knew it. One side is all answers. The other side is all not answers. I always think about like Jets fans, Giants fans. Right? Yankees, Mets, maybe. I don't know. There could be some overlap there. Red Sox, Yankees. There you go. It's even better. I won't tell you which side I'm on. Go Sox. All right. Anything else from homework stuff? No. Okay.
Yeah.
Oh.
A2, number 85.
Oh, yes. Yummy. Okay. I'm going to take all this away.
Yeah. Thank you.
Sure. So this is 8 to 85, right? So the way math works best is there's an idea. From the idea, you build up a process. And then you just use the process. So this whole thing about absolute value greater than being a stay the hell away from me, absolute value less than being stay close to me. That's the idea behind what we do. If I see a greater than, I do something or something else. Less than, or whatever you want to think about it, is negative something less than the other thing. It's a sandwich. And it is because of the idea. If I want the distance to be less than something, so here I am, that's me, and I want the distance between you and me to be less than 2, how far away up here can you go? Up to 2. How far down here can you go? Negative 2. And then I want you to stay in there so you're close to me. Less than is a sandwich. It's a negative 2 less than x less than 2. That's how I can rewrite this. I can rewrite this because that's what that would be. So can I explain why this goes directly to there? Not directly. I do it through the idea. And then I say, oh, we could rewrite it like this because that's what it would do. Period. Right? So this is a greater. Don't worry about the fraction shit yet. It's just stuff. So what do I do? This is greater equal to 2/3, or this is less than or equal to. Yeah, why do we flip the sign? Because we multiply by negative. Yes. Oh,
Oh, no, I'm good.
now you worry about the fact there's just fractions, but how do you take care of these fractions real easy? What can you do? Cross multiply. Right. 3 times this, 4 times that. Remember that good old cross multiplication stuff? Yes? No? You could do LCD and you get to the same place. Because cross multiply is a shortcut of LCD stuff. When's the only time that it works? One fraction on one side and then one fraction on the other side. It's the only time it works. So you can do the same thing over here. Is that decent? So I think the problem with that one was, there's fractions all over the damn place. But once you write the cases, you can immediately destroy those fractions. It's very satisfying. Yes?
So after that you would subtract.
Yeah, now it's normal stuff. right? Now you forget where it came from. The fact that it used to look like this has nothing to do with my next step. I look at what I got and I go from there. All right, so yeah, you would subtract 6. And then? But divide by? Negative 15. And when I do that, what has to happen? That's one thing. Now you can do the other thing, right? So your brain right here says, I can't divide by 15, it's bigger than 2. Or, I don't want to make a fraction. No. What's the process say? Why is x not by itself? Stupid negative 15. It's multiplying. How do I kill it? Divide by it. There's no choice. You can't escape this gross fraction. Too bad. The nice thing with the problem is I'm done.
And that would be a vertical line, right?
Oh, okay. This is section 8 too.
Oh.
This is not xy. This is purely one number line for x. Is that cool? Okay. All right. And of course, you still have to do the other case, but I want to leave you a little bit of something for your homework. Somebody's like, you don't have to, Jeff. Yes?
The question was that, like that, just by itself, x less than or equal to negative. Blah. Yeah, if it was only that negative, that would be no solution, right? Because it's a negative.
Okay, so where is x in the original problem? Where is it? It's inside something. Where is it inside? It's inside the absolute values. Can you put a negative into an absolute value? All day long. So there's not a damn thing wrong with this being negative. Does that make sense?
But that was the question by itself.
The sub said something about if on that side if it's negative, it's no solution. I know she did say something.
All
about
right. So you got to be really careful when you say things like that to make sure that you say it's when there's an absolute value. In fact, remember I said that yesterday, was if you have an absolute value, there's no absolute value here. But if your question is this, if this was the problem, then there's no solution. Why? Absolute value has to come out at least 0 or positive. It can never be less than a negative number. That would be no solution. You could stop right there. I like no absolute values here, so this is fine. I like it. But I also have people that throw out negative answers because it came from an absolute value problem, but you can put negative numbers in absolute values. In fact, that's one of their main things, is to make things positive, right? All right. Anything else from homework stuff? Or just general? Question about a proposition yesterday? No. Got to be careful, man. They word some of those so that they're the opposite of what they actually do. Sneaky bastards. Yes?
I don't know if I was here for like this day when you taught this, but like 8.1, 1 through 15, or mostly 1 through 10. Like, how do you know which, like, the union sign and the and sign and the or?
So, what does this mean?
And
Or
or
And this, of course, means,
and
because it looks like an A that's missing its bar, right? And this, I love this one. It's like you or you. Somebody do that shit, right? Okay. So if I said x less than negative 2 or x greater than 5, more than likely it's going to be this thing, right? You're over there or you're over there. In fact, if you graph this thing, which is really what this is asking you to do, just graph it and then match it to which one it matches. So to graph this thing, it would be negative 2, and I'm going to put what on negative 2? Parentheses, I'm going to shade it which direction? Yeah, down. You got to love that shit. As long as the variable's on this side, that is an arrow. and then 5, arrow up. So there's the go there or there, right? Or you can think about it like a mom is like, God, get away from me. Just go over there, over there. You've been in my hair all day. Okay. All right. Is that all right? I mean, basically every single one of those problems, you graph it and then just match the graph with what they got there. You'll see which one matches what you just did. The tricky ones, all right, let's do the same problems. Everybody cool with that? The interval notation would be negative infinity to negative 2 or 5 to infinity, blah, blah, blah. Separate. If I would have put the word and in here, that's an exceptionally freaky problem. Give me a number that is less than negative 2 and greater than 5. Give me it. What number does that?
Would that be no solution?
Is it bigger than 5? See, so it's got to be less than negative 2 and greater than 5, right? You with me? There is nothing. So if you try to do it, I mean, we just had this up here. Here's negative 2 and down. Here's 5 and up. Where do those overlap? Because that's what and is. Where do those overlap? Nowhere. So there's no solution. So normally an and will be this. But it's possible that it's like, oh shit, now there's no solution. Normally an or will be this. But it's possible that you'll get this overlap and then it's all real numbers. If you've done the homework, you've seen that. So if I do an or problem, here's an or problem that would be all reals. X greater than 5 or x less than 7. Give me a number that doesn't match that. 6. 6 is less than 7. Right? It's or. That just has to do one of them. 8. 8 is bigger than 5. 0. 0 is less than 7. You can't come up with anything because if I do greater than 5, less than 7, that's everything. Because or, what does or do? Or takes everybody. Or is the nice bouncer. Right? It's like saying you can't get in here unless you're over 21. Or less than 23. It's like, that's every freaking person. What are you talking about? It's a little too nice. No? Little 7-year-olds walk around, you do it. No, it's not a good thing. You don't want your bouncer too nice. So and is the mean bouncer, or is the nice bouncer? It lets everybody in. How are we doing there? I saw some pained looks, but I'm not hearing any questions. Pained looks, I don't know. I'm not a doctor. Don't know what to do for you. So again, let me say this again. Or will almost always be this separate thing, right? You could be there or there, but if they overlap, then you get all real numbers. And is normally the sandwich. Stay close to me. But again, sometimes you'll get no answer. All right, that's enough of that. The real thing I want you guys to get over is if I have this, I know we've done this, how can I immediately rewrite that? It's a less than. I want to stay close, which means there is a bottom and a top. So I can rewrite this. 2x minus 1 has got to be between two things, right?
Positive 5 and negative.
Yeah. That's a huge thing, and that just makes sense. If I don't want you to get more than 5 away from me, so this is me, and I don't want you to get more than 5 away from me, you can go up to 5 or down to negative 5. Stay close to me. Don't get away from me. So you can be 5 feet in that direction, 5 feet down that way. So that's why writing like this makes sense. Did I do something algebraically to this to make it become this? No. I used an idea. And I think that's why some of you guys balk at this. You're like, how did you go from there to there? What did you do? I used a freaking idea. Right? That's what I did. Stop doing that, Jeff. Okay, maybe.
So why this is all number? Because I tried to solve like add one.
Yeah, so there's one, that's almost exactly the same thing. So again, if I said this How do you know that's a special case? You stop and think about it. How do you know it's a special case?
Can't be greater.
There's an absolute value problem with a negative. Now be careful. Absolute value has to be bigger than a negative number, no matter what. So what's the answer then? All real numbers. There's no x's that won't work, because every x you use gives you a number, and they all have to be bigger than negative, because it's an absolute value.
If it was a negative 5, how would you solve it?
If this is the problem.
Yeah, no, it's a...
If it wasn't a negative 5.
Yeah.
If it was a positive.
Yeah.
Okay, so how do you do this one then? Great tour. So you write 2x minus 1 greater than or equal to 5, or 2x minus 1 less than or equal to? There you go. There you go. Greater. Stay the hell away from me. Bam. Separate. That one is going that way, and that one's going that way. Get away from me. Yes?
So if it's a less than, you do it the other way, right?
If it was a less than, I can write it negative 5 less than this, less than equal to 5. Yeah. So less than, stay close to me. It's got a floor and a ceiling. It's got the negative thing and the positive thing on either side. Stay close to me. Greater than is the opposite. Stay away from me. You can't write it in one single line because it's a collection of numbers and a whole other collection of numbers, separate. You can't write it in one line. Maybe. All right. Anything else from homework stuff? This is good because we got that quiz in chapter 8 tomorrow. Okay, all right. So we're going to get back into 10. Let's go back in the green book, I think. We'll start here. I'm going to actually start on page 174 and work back a little bit. Thank you. Well. All right, guys, so page 174. This is asking me, yes?
The square root stuff can be on the quiz.
No. Quiz is chapter 8. Square root stuff is chapter 10.
Oh,
Next week we'll have a square root quiz. Yay! Let me get you to remind me. So there's the problem we're going to work on in a minute. Let me do an earlier problem just to remind you how this works. What if I ask you to find the domain of this? Let me write that again. See how I'm trying to use the same thing? See that? Must be some connection I can make. Can somebody, don't try to solve this in your head. Just tell me, what is it about this function that might lead to a problem spot? What kind of function is this? If you put a 1 in there for x, what do you get? Try again. What do you get? You get a 2 where? The bottom. So what do you get? 1 over 2. You get 1/2. In fact, for almost every value of x, you're going to get a fractional answer. Right? So this is a rational function. Remember those? Rational functions, ratios of polynomials. Okay. What can't happen in that kind of thing? The bottom
Cannot be 0.
cannot be 0. I love it, right? So whenever you see the question, find the domain, and they give you some functions, can you say in English what the problem is? Because then if you can translate that to math, you're golden. So what is it in English? The bottom can't be 0. Okay, what's the bottom? Translate it to math now. What's the bottom? What's on the bottom? 3x minus 1. Cannot be. I'll do that one for you. Not equal to. 0. And if I solve that, I'm going to get the one number that makes it 0, and I'm going to throw it out. All right, so if I add 1, divide by 3, I get 1/3. So x cannot be 1/3. So my bold claim is, I don't give a shit what kind of function it is. If you can say in English what the problem is, or what has to happen, and write it in Mathish, you solve it, you're done. So what is it we've been talking about? Square roots. What kind of square roots can I not do yet? What kind of square roots come out to something that's not real? The inside would have to be negative. So what has to happen for this to be okay? The inside has to be not negative. What's a better way to say not negative? Yeah, not really, though. You're missing something. Inside must be positive or 0. So greater than or equal to 0. So that's in English what has to happen. So over there, the bottom can't be 0. That's what has to happen. We translate it to math. We solve it. We're done. Here, the inside must be greater than or equal to 0. So what's the inside? What's inside? 3x minus 1. Greater than or equal to 0. And can you solve that? Yeah, you still just add 1, divide by 3, right? But now you get x greater than or equal to 1/3. So look what happens. Is 0 an answer? Is 0 something that will work? Is it bigger than 1/3? 0. Is 0 bigger than 1/3? Or you guys, can everybody say xylophone? All right, see, that's the best response yet. Is 0 bigger than 1/3? No. So try to plug 0 in. What do you get? Square root of -1. Can we do that yet? No, it's not real. So this whole thing about domain is always talking about real numbers. So what did I just do? I just took a number that's not bigger than 1/3, plugged it in. Something freaky should happen. Because this says, here's all the x's that are safe. So if I use something that's not this, it should come out weird. And it did. I can't do the square root of -1. How are we doing? So here, again, there's a radical, right? So basically, the English statement is always the same for a square root. The inside has to be greater than or equal to 0. So the inside, greater or equal to 0. So what's inside? 4 minus x. So that number, whatever it is, has to be greater than or equal to 0. Solve that real quick. Oh, yeah. So I feel bad for you guys. Some of you guys like the way she explained things better than me, and she definitely has better handwriting than I do. So if you missed that day, there's what you could have had if you took Sarah. You took me, so you get this. How do I solve this? Minus 4. So let's try it. What's not less than 4? 5. 11. What happens when you try to plug a 5 in? 4 minus 5 is Ah, shit. See, I get a number that doesn't work. So if I use an x that doesn't follow this, I should get something that freaks out. Domain means all the x's that give you a nice, normal number.
So what do you do with 3?
I'm sorry. Oh, okay. I really want this to make sense. So remember this guy? If I said plus 3, none of my work changes. Because what's the only part of this thing that could have a problem? This. What's the only part of this that could have a problem? This. 3. I can't make 3 mess up. 3's like, I'm 3. What are you gonna do to me? I'm 3. This is the part that has an X in it, so this is the part that can change and maybe become something extra weird. 3 is just 3. So the only part of this whole function that can mess up is this part. That's why I don't care about this guy. Does that make sense? Like here, do I even give a shit about the top? Did it matter that the top was 1? What if I made the top 2? Does that change anything? Because the only part that has a problem really is the bottom. The top's okay. So it's the same idea of we focus on the part that might have a problem. So in any radical problem, if it's an even root, we'll talk about more of that later, then the inside can't be negative. It's got to be greater or equal to 0. I like it. Now look at this one. Now think about this. In order to work, the inside has to be 0 or positive. Can you ever make this 0? Think about it. What's the smallest x squared can be? 0. And then I'm adding 4 on top of that. So what's the smallest this inside can be? 4. So is there any value of x that will make the inside become less than 0? No. So what's the domain? All real numbers. There's no value of x that makes the inside less than 0. Therefore, which value is going to use? All of them. None of them freak this thing out. Notice this is a sum of squares. If it was a difference of squares, it actually would be a much harder problem. We'll do that problem later this semester. All right. Yes, sir.
So for number 2, so the way to check your answer is before.
Yeah, one way is to either use, like, plug a 0 in, and you get something you can do. Even if I plug a 1 in, I get 4 minus 1 is 3. Is the square root of 3 okay? Like, does it freak out? Is it a gross number? Yes. Is it like a freaky number? No, it's real. It's okay. Square root of 3 is gross, but it's fine. But if I try to plug in something that doesn't follow this, like 5, I do get something freak out. What's 4 minus 5? What's the square root of negative 1? I don't know. Jeff said something about imaginary bullshit, so I'm not, that's freaky, right? So if it doesn't do this, it should make things freak out somehow. Just like up here, if I plug a 1/3 in, what happens? I get undefined, which is our original freaky. Now we're starting to realize there's more freaky ways to be freaky. Okay. So let's go back. I just wanted to do that before we did this. I'm not even going to do this in the graphing calculator. I think that's lazy. You would, Jeff. Can you guys tell me the domain of this? What part of this could have a problem? Is the plus 5 under the square root? No. See how it's outside? So, what could have a problem? This guy. What's got to be true about x? Yeah, bam! X has got to be greater than or equal to 0. So what's the domain? 0 to infinity. Now, let's try to graph some points. What do you get when you plug a 0 in for x? Plug a 0 in for x. What do you get? 0 plus 5 is 5. So at 0, it's at 5. What do you get when you plug a 1 in? Square root of 1 is 1 plus 5 is 6. It's crazy. So at 1, It's at 6. What about if you put a 4 in? Now, why am I jumping to 4? Because 2 and 3 give me gross answers. 4 will give me a nice round number. What's the square root of 4? 2. 2 plus 5? 7. So at 4, it goes to 7. So here's that shape we talked about the other day. Remember that? So what's the range of this? What's the lowest output? Yeah. Lowest output is 5. And then it goes forever up. So I want you to realize, if that plus 5 wasn't there, what do you get when you plug a 0 and you just get 0? Right? Right? Stay with me now. Look at what this plus 5 does. It does exactly what you hope you could say it does. What is that plus 5 going to do? It's going to take all those outputs and make them 5 bigger. Because it's adding frickin' 5. So normally we would have been at 0, 0. This is for the square root of x. What's the square root of 1? 1. What's the square root of 4? 2. So that's where the square root thing normally is. Look, it went up 5. It went up 5. It went up 5. Why did it go up 5? Because it said to go up 5. Isn't that neat? So if I would have put the square root of x minus 3, what do you think is going to happen to the picture? So there's the square root of x. And now what's going to happen with every point? It's going to go down 3. Isn't that kick-ass? This is something called transformations of functions. I don't care what this function is. Whatever it looks like, if I put a minus 3 after it, the whole thing is just going to go down 3. Okay, maybe. So this guy would go 1, 2, 3 down. 1, let's see, it starts here. 1, 2, 3 down. Where am I going here? Here we go, Joe. 1, 2, 3 down. At 4, it's normally a 2. It'll go 1, 2, 3 down. Let's double check this. When I plug a 4 in, what do I get? What's the square root of 4? 2. 2 minus 3? 2 minus 3? Negative 1. Where's the point at 4? It's at negative 1. So if I took every point on this and did what to it? What does it say to do? Take 3 away. So if I take every point and move it down 3, I get this picture. And that is what this looks like. Because what happened with the plus 5? It just took this and moved it up 5. Now here, what's different with this problem from the other two that we just did?
Everything's over the...
Yeah, that 4 is inside with the x. And x, what's the x-axis do? It goes left and right. So if it's in with the x, watch what's going to happen. First off, how do you figure out the domain? What can you write down to figure out the domain? What's got to happen? Beautiful. So x minus 4, the whole damn thing is inside. So that's the inside. So x has to be greater than or equal to 4. So I can't even use values until I get to 4. I can't use 0. What happens when I plug a 0 in? Square root of negative 4. I can't do that. So 4 is the first thing. And when I plug a 4 in, of course, what do I get? Square root of 4 minus 4. I get 0. Are you guys cool with that? If I plug a 4 in, I get 4 minus 4. I get a 0 on the inside. And look what just happened. Normally, the picture looks like this. Now it's starting here. It moved over 4. It looks like it does the opposite of what this is. But let me ask you this. Whenever I plug a number in, what's the first thing that's going to happen to it? Like if I plug a 5 in, what's the first thing you do to it? If I plug a 5 in, I subtract 4 first. Right? So the picture, to make the picture, all my inputs have to be 4 bigger than they used to be, because the first thing I do to them is take 4 away from them. That's why the picture actually ends up moving up. All my inputs have to be 4 bigger than they used to be, because the first thing I'm going to do to the poor little dudes is take 4 away from them, right? It's like if I give my kid $10 to go in the movie, and the movie's actually $12, I'm like, I better give you 2 more frickin' bucks, because they're going to take 2 away from you. Shit. So the first thing you do is take 4 away from you. I better give you 4, or you're not going to be able to get in there and see the movie. Well, nowadays, maybe that's a good thing. If I put a 5 in there, 5 minus 4 is 1, square root of 1 is 1. So now it looks like that. Whee! So it just took this picture and moved it up 4, like that. And of course, what do you think is going to happen here then? What do you think it would do to this normal picture? What would happen to the picture with this? If x minus 4 went to the right 4, square root of x plus 2 should go to the left. And why does it make sense? What's the domain going to be? -2. Now it starts at -2. It's allowed to start at -2 because I add 2 to it at first. So it can be less than it used to be.
Why didn't you change the sign? Because it is now.
I didn't divide or multiply by negative. All I did was subtract 2. I like it. All right. So that's mostly baby steps into this idea of transformations. That's definitely going to come up more later. I could tell you guys, love that. When we get to quadratics, when we get to parabolas, we will definitely do a lot more with transformations. This is just like a little baby step for right now. All right. So here, can you guys do me a favor? Fill in this table up here. This is page 171. I think that's all I wanted to do over there. Yeah. Page 171 at the top. You guys, everybody aware of what you're doing? Fill in that table in at the top there. If you want to play along. So you left in the cubes. So some of these you should remember from when we were factoring sum and difference of cubes. What's -4 cubed? No.
-6.
-64. So see how odd powers keep the sign. Because if it's negative, then these two negatives kill each other, and these two negatives kill each other, and there's always a negative left. So when I cube something, the sign stays the same. When I square something, it always comes out positive, or 0. What's -3 cubed? -27. -8. -1. 0. 1. 8. 27. 64. 125. 216. 216 I won't make you memorize, but we've seen 125 before, remember that? We've done a few with that. You've definitely seen everything in between. Okay, so, what does this mean then? Well, what's the cube root of 27? 3. So what does this symbol ask you? So later this semester we're going to learn something called logarithms. And people hate them because they don't take a minute to realize these are relatively simple, right? Like square root of 9 is an easy question. Why? Because you've internalized what the square root symbol means. You know what question it's asking you. What's the cube root asking you? What does it take 3 of to multiply to be this? So what would a fifth root ask you? What does it take 5 of to multiply to be the inside? That's what they always ask you. So then that gives you a plan of attack. If it's a big-ass number inside or something, you can at least start to attack it. But the cube root of 27 is easy. Like you guys said, it's 3, because it takes 3 3s to multiply 27. What is the cube root of -8? -2, because it takes 3 -2s to multiply to be -8. So cube root cuts things in thirds. That's why it's related to factoring its difference or sum of cubes. Oh, God. this poor thing. Let me try to tease out what it looks like that. I think it's the cube root of b to the 6th. Boy, they really had some interesting times. What do you think the cube root of b to the 6th is? B squared, totally. Because what's a cube root do? Cuts it in thirds. Look at this easy kick-ass thing. 3 goes into 6 twice. So what's the fifth root of b to the 15th? B3. 5 goes into 15 3 times. So if I cut 15 into 5 parts, it's 3s. Right? That's all it is. Gotta love that shit. So what about this dude? Beautiful. And I don't have to worry about absolute values with odd roots because they leave the sign the same. It can come out negative. We just had it there. There's a one that came out negative. So if you put absolute values on this, you will lose points. Because that can't be right. It doesn't have to come out positive. It has to come out to whatever the sign is. Does that make sense? So it's only even roots that are all uptight. Can I factor sum of squares? No. Can I factor sum of cubes? Yes. So squares and square roots are uptight. Odd roots and odd things are not, because they leave the sign the same. I'm hoping it makes some sense. Blah. Here we go. I like this one. So try to do this one. This is what I was talking about earlier, a plan of attack. Just make sure everybody's looking for the right thing. The answer to this would be the number that I need 4 of to multiply by 256. Okay, so now that should give you a way to attack this number. Try it. Don't say anything out loud. Unless you want to talk to somebody else, that's fine. About this problem. Curious what you guys are trying to do. What did somebody do? What have you done? What did you do?
I saw the 4 and started multiplying by 4. Yeah.
Did what now? Sorry?
I saw the 4.
Yes?
Outside, so I just started with that.
Oh, okay, sure. So 4 times what?
4. And well, I just multiplied 4 times 4 times 4 times 4.
Oh, I see. To check to see. All right. Well, 4 does go into 256. 64 times. And 64 should actually be a number you can just go straight to. What is 64? It's 8 squared, but it's also 4 cubed. So how many 4s do I have inside? 4. So another way to look at roots. Why can I do the square root of 9? Because 9 has 2 3s. And the square root is looking for 2 things. Why can't I not do the square root of 5? Because there's only one 5, right? I can do the square root of 25, because then there's 2 5s. Why can I do the cube root of 8? Because 8 has 3 2s. You guys see what I'm saying? I can't cut something in thirds unless there are 3 things in there, right? So I'm trying to cut this in fourths. Well, what is there 4 of? There's 4 4s. 4 times 4 cubed is 4 to the 4th. So that's why the answer is 4. What does it take 4 of? It takes 4 4s to multiply to be 256. Chapow.
Is there a way to do this in the calculator?
Yes. I'm not going to tell you yet. Yes?
What about like on 3 with a negative on the outside?
I love it. So then you do that problem, and you put a negative on it. Because that is what it says. It says the opposite of the 4th root of 81. Well, okay, if I can figure out what the 4th root of 81 is, let's put a negative on it.
Okay.
Yeah. What is the 4th root of 81?
3.
3. Because 9 times 9 is 81. Therefore, 3 times 3 times 3 times 3, 4 3s make 81. So this is 3. And then I just put a negative on it. Bop. Why is that okay? Why is it not imaginary or something? Because the negative, like you said, is on the outside. If I said, what's the 4th root of negative 81, what's the answer? It can't be negative 3, because what's negative 3 times negative 3 times negative 3 times negative 3? It's going to be positive.
The absolute value.
Absolute value, you can't save your ass here. No real number. It's not real. I can't take an even root of a negative number, because if I have an even number of things, it will come out positive. Even number of real numbers. So this would have no solution. Why was this okay, though? Because the negative is on the outside. So it doesn't affect this. It's just sitting on the outside waiting. It's like, you done yet? Oh, you're 3. Okay, now you're negative 3. No idea if that's what it sounds like. All right. Oh, let's see. These should not be a big deal. Let's see if that's true. Do number 2. You see what they want you to do? They just want you to throw that value in. So this shouldn't be a big deal. It's just throwing stuff in and then do it. Nothing too special about these. Just be very used to this kind of thing. So what is f of negative 5 is what they're asking. So you throw a negative 5 in. What's 5 times negative 5?
Negative 25,
Minus 2.
negative 27,
What's the cube root of negative 27?
negative 3.
Bam. So it's just plug and shove, right? So those kind of problems should not be a huge deal. Shouldn't be. I have no idea what this problem is trying to be. Oh, I see. And still, you would just plug a 9 in. So it's trying to be this. So what's f of 9? It would be the square root of 9 minus 5. Minus square root of 9 over 2. What's 9 minus 5? 4. Square root of 4 is 2. Square root of 9 is 3. So you get negative 1/2. I mean, so those are problems, I like to say this, you can sink your teeth into. I mean, you can just grab a hold of it and just do it. There's nothing weird about it. There's no idea to apply. It's just straight up, do the numbers. Okay. Trying desperately to get to this. That was neat. Oh. All right, before you... What operation are exponents based on? Multiplication, 11, right? What does the square root do?